morning.
How's everyone doing this morning?
Pretty well, you?
Good, good.
We're all excited to have you here. Do you have slides that you want to share?
No, I don't. I thought I
that's
would,
fine.
yeah. I thought I would just talk a little bit, and hopefully you guys will, everybody on the call will feel free to ask questions as we go along.
Yeah, absolutely.
Sure. So do you want to just get started, or?
So just to be clear, you're fine with students asking questions while you're speaking?
Absolutely, yeah. Please interrupt and anytime you want. I'd much rather answer questions than just talk.
All right.
Dean Perez, could you just give just a quick snippet and background of your career and also your involvement in space?
Sure. So I'll try to give you this brief bio. I promise I won't tell you my whole life story, but the things that are relevant to it. So I grew up in Virginia. I'm a first generation student, so neither of my parents went to college. I'm the youngest of 5 kids, so grew up in a big family. My dad worked as a mechanic the second half of his life, so I grew up working on cars. So there were 2 things that led me to study engineering. One is I thought I wanted to design cars. And then also one of the most vivid memories I have of a child was the Apollo moon landing and watching the Neil Armstrong on the moon. And it fascinated me for a bunch of reasons, but later on in life, what fascinated me as I went through, I was 7 years old at the time of the moon landing, as I continued on through school, was how did they get the picture of Neil Armstrong from the moon to the earth, right? And I'll come back to that in a minute. So I always had, growing up, I was the stereotypical things of good at math and science, but also because I was always working on cars. My dad was a very handy person, and so I was always fixing things. And I was just fascinated by how things worked. So I decided to study engineering. I actually did start as a mechanical engineer, but I took dynamics and couldn't stand it. So I switched to becoming an electrical engineer, which was a good decision for me. And I did my undergraduate at the University of Virginia. And then I did all my graduate work at the University of Notre Dame, where I got my master's and my PhD, all in electrical engineering. And then I did a postdoc in Switzerland at the ETH, which is the Swiss MIT, if you will. And then I've been at Nebraska for 25 years as a faculty member, and I'm now the Dean of the College of Engineering. So that's sort of the career arc. As I said, my fascination with engineering and space really began with NASA and watching that moon landing. And then after that, I paid attention to everything NASA did. So I paid attention as they, continued the rest of the Apollo missions. Of course, I watched Apollo 13 live when they had the disaster and had to get back, and started paying attention as they started developing more and more of the deep space probes. So, so Voyager 1 and Voyager 2 launched around that same time period. And then that became the emphasis actually of the space program. After the Apollo program was shut down, they started to focus more on deep space probes. And so when I was an undergraduate studying electrical engineering, it really wasn't until about halfway through my junior year that I really discovered what I loved about electrical engineering, and it was communication systems, particularly digital communication systems. So when I went to graduate school, I wanted to do research in digital communications. And I was very fortunate that at the time, there was a faculty member at Notre Dame, his name was Dan Costello, whose research area involved deep space digital communication systems. So, and he had funding from NASA, from the Goddard Space Flight Center in Maryland, who's responsible for designing the communication systems for most of the NASA missions, all of them from the space shuttle to deep space. And my advisor had a grant from them. And so I got my dissertation focused on designing digital communication schemes for NASA. So I did work on what's called Advanced TDRS, which is TDRS stands for Tracking Data Relay Satellite System. It's a set of satellites that NASA uses to communicate with all of their space vehicles. And we also did some work on the Deep Space Network, which, have you seen the movie Contact? You know, so there's NASA has these three huge antennas, one in Australia, one in Spain, and one in California. They're the biggest antennas in the world, and they use those for communicating with their deep space probes, right? And they do some synthetic aperture communications. And so I also got to do some work on that. And then when I was doing my dissertation, there was a probe called Galileo that was being sent to Mars. And as it went to Mars they went to deploy the antenna, and there was a failure. And what they figured out was when they were installing, when you send up something to space, it has to be compacted to make it small enough to fit on the rocket, right? And then once it gets outside of Earth's gravity, things unfurl. So you've seen in movies the solar panels rolling out, and then the antennas have to, bloom out like this into that umbrella shape. Well, when they installed the antenna, they had miswrapped a cable, and it prevented the antenna from fully deploying, which meant its gain was significantly reduced, which meant they were going to lose communication with it as it approached Mars. So in real time, we had to redesign the communication system, upload it to the probe, and reprogram it so that that smaller antenna aperture would work. And my dissertation actually was focused on digital coding schemes that would enable something like that. So something called concatenated codes. So I was really fortunate that my dissertation work got to focus on space communications because it's fascinating to me. What fascinates me about space most is it's such a hard problem, right? I mean, it's an unforgiving, and it's just an amazing engineering challenge. It's an unforgiving environment. You can't fix things, right? So the standard of design is just unbelievable, and it pushes the limits of everything. I mean, if you think about Voyager now, it is billions and billions of miles away from Earth right now. It's an interstellar object, and we're still communicating with it using a communication system that was designed in the 1960s, right? And I mean, it's an amazing piece of engineering. And then, I mentioned the Deep Space Network and those antennas. They keep upgrading those antennas and re-engineering them so that they can continue to communicate with Voyager, both Voyager 1 and Voyager 2, because you can't change Voyager 1 and Voyager 2, right? And so, in fact, right now, they're upgrading the antenna in Australia just so that they can maintain communication with Voyager. And so it's just, to me, a really amazing engineering challenge that requires it has incredible constraints. So another interesting example, I don't know if you've heard of this story before, but the space shuttle, when it was flying, the computing power that the space shuttle had to run its navigation systems was smaller than what computers had in the 1960s, because you can't just take an Apple M1 chip, right, that just came out and put it up into space because of all the solar radiation. So you have to go through this hardening process to develop a processor that won't be affected by that kind of radiation. So the kind of technology that goes up in space vehicles is usually at least a decade behind what you have in your laptop, because it's such a harsh environment. and so I don't know, I could go on forever about this. But engineering for space, I just think it's one of the coolest engineering challenges that are out there. You know, it requires engineering from everything. You know, I did communications on the electrical side, but you need great materials. So there's a lot of really complex mechanical systems up there. When you think about all those solar panels and antennas unfurling and having to do that reliably and having to do it with such low weight, when you think about you know, the operations, you know, how much software there is now on space vehicles and how accurate that has to be and how reliable it has to be and how it has to be able to adjust. I mean, if you think about, again, I geek out on this stuff, so you guys can tell me stuff. But you know, when a bunch of the rovers that have been on Mars have had all sorts of problems, that they get up there, they encounter something that they didn't know because they don't, you know, that's why they're going to Mars, is to try to find out what's up there. And the software has to recode itself on the fly to adjust to the conditions and the situations that they're encountering. You know, so they design a sampler to go into the soil, and it has a certain pressure and a certain speed, but the soil's different than they expected, so they have to be able to reprogram that. And so it's just fantastic engineering. I think it's really, really neat. And I can get into the philosophical side of space too. But I just think it's really fascinating. And again, I've been really fortunate that for a long part of my career, I got to do work that was related to NASA and to space. And I still find it very motivating, even though I don't get to do that kind of work anymore. So John, was that enough? Or
I think that was great. Matter of fact, I learned something about you that I didn't know. So that was outstanding. I'm going to let John Helzer moderate this because I know we have questions for you.
Sure.
Yeah, does anyone want to start with a question that they have for the dean?
So I saw Elsa raise her hand, yeah.
Yeah, so do you have any like specific traits or qualities you think helped you be successful?
Sure. I think, you know, so it's a trait I have, but I think I've also, you know, having spent the last 30 years of my life in higher education, I see it in a lot of our students as well. I think a really important trait, there's two really important traits, I think, for engineers. One is creativity, right? You have to be able to think and try new things and you know, imagine things that aren't possible, right? And that haven't been done. So creativity is a huge part of engineering. The second is persistence, right? And the realizing that, you know, when you're going to try to do something, to design or build something, the first time you do it, it's not going to work, right? It just isn't. That's just not, you know, and you have to be willing to learn from that experience. You know, okay, so I have a design, it failed. It's going to happen. It happens every day in engineering. What worked about the design, what didn't work about the design, what worked about the process, what didn't work about the process, and then go on to the next step and try again, because that's all good engineering works that way. If you've watched any of the NASA movies, right? I mean, they're full of rockets blowing up, things crashing, right? Because, and that is true of engineering, that things fail and you have to learn from it and then be creative, come up with the next version that you're going to try. So I really think those two things are the biggest characteristics of engineering.
Yeah. Did you have any specific like role models you looked up to?
I did. So I would call out three, and one, you know, I don't know if you've ever heard of Kelly Johnson. Has anyone heard of Kelly Johnson? He was the head engineer at the Lockheed Skunk Works in California. So he designed all the cool planes of the 20th century. So the U-2, the SR-71, things like this. He was a brilliant aeronautical engineer. And I grew up I was fascinated by those aircraft when I was a kid, for reasons I'd be happy to tell you about. But and so he was a real role model for me as an engineer, right? That because he was constantly solving new problems and doing stuff that people thought couldn't be done. I mean, if you look at the SR-71, for example, are you familiar with that plane? The SR-71, the Blackbird? It was the last of our spy planes. That you could go down to the SAC Museum, and they have one on display there, and I would encourage you to do that. So that plane flew at extremely high altitudes and extremely fast speeds. So it actually stretched in flight by a couple inches, all right, because the heat it generated on its skin was so high. So in order to make the plane work, they had to build the fuel tanks so they actually leaked when they were on the ground. And as the plane stretched and expanded at flight, they would stretch and expand and seal, right? So what engineer would build an airplane that had fuel tanks that leaked, right? That were designed to leak? And it literally did. If you watch, I think you can find this on YouTube. You'll see an SR-71 on the ground, and you can see the fuel leaking. And then it takes off. And once it gets to altitude, they actually have to send up another plane to refuel it because it lost so much fuel. And then it takes off, and goes to speed, right? So Kelly Johnson was a real inspiration to me. And then my other role model was I was really fortunate that I had great faculty mentors, both as an undergraduate and a graduate. As an undergraduate, I'll tell you something about myself, but don't spread it around. I wasn't the best student as an undergraduate, right? For a lot of reasons. I mean, I did okay, but I was doing a lot of other things as an undergraduate. But my advisor sort of understood that. And when I just went to graduate school, he wrote me a letter that got me into graduate school, right? And to have a faculty member be able to see, what my potential was and realize that it's not just always about GPA and things like that, was a real lesson for me. And then when I got to grad school, my advisor, Dan Costello, I just couldn't have asked for a better mentor. I mean, he was a fantastic engineer. He was one of the 5 best people in the world in his area. But he was also a man of deep character and integrity, and really, taught me how to do things the right way. So, good questions. Yeah.
Yeah, absolutely. Gavin, do you want to ask yours?
What were some things that us as like students, middle schoolers could do from like here till high school and college that could help us prepare for like this kind of field?
Yeah, well, so there's a couple of things. I mean, the reality is it starts with your basic education. That make sure you're taking math and science courses. They are the foundation of engineering. And so you want to make sure you're taking those classes and doing well in them and understanding them, because you will use it as an engineer. You will make use of math and science. It is, engineering is about the application of math and science to the human condition. So that's one thing. The other thing is, though, I would try to get involved. There's all sorts of programs. This is an example of one, right? The CubeSat program is an example. And there's all sorts of opportunities to get exposed to the various engineering disciplines and science disciplines through summer programs, through extracurricular activities. And I'd really encourage you to do that, and, for a couple of reasons. One, I think as students who are going to become engineers, sometimes will get frustrated with the math and science because they don't see it being applied to the types of engineering problems that are fascinating you. And by participating in programs like that, you'll get to see that, and you'll get to understand that, start to value the math and science, not just for itself, but because you know how it's going to help you solve problems. And then also, the more you get exposed to it, the more you'll start to understand what engineering is, and what the various sub-disciplines of engineering are. So you'll be better prepared to think about what kind of engineering you want to study when you do get to college.
One more question. Did you do anything that you would like, kind of like what I mentioned between middle school and like college that helped you?
Not so. You have to. It's a fair question, but I'm from a different generation where we didn't have the kinds of opportunities that you guys have, quite frankly. And I grew up in one of the best school systems in the country. But one of the things I did do, though, I was just fortunate that one of my best friends when I was in middle school and high school, his father owned an engineering company. It was a chemical engineering company, actually. And I went to work there. Actually, I went to work there as on a construction crew. I wasn't doing engineering, but even doing construction, you get to see, I was wiring things, you get to learn some basic things that are related to engineering, but I was also around scientists and engineers, and even though I didn't fully understand it, I got to see some of the things they were doing, and it helped me understand what engineering was. And my friend's father was also very gracious, and he would take us around and explain what the company was doing. So that's the primary thing I did.
Hey, I think Tegan has a question too.
So I also have two questions. My first question is, what kind of led you to become a dean? Like, do you sometimes wish that you were still or do you sometimes wish that you could do like hands-on activities or projects? Or like, what kind of led you to be the career position that you're in now?
Sure. Wow, you guys are asking really good questions. Yeah. So, I'll just address sort of the second part first. That I became a professor very deliberately, right? And I love that job. It is the best job I ever had. And one of the things that I'm fortunate is that I'll always be a professor, and when I stop being a dean, I can go back to being a professor. It's one of the great things about this job. I love that job. It's the perfect job for me. I love all parts of it. I love teaching. I love research. I love working with students and companies. So it's the perfect job for me, and I really couldn't have asked for a better career. And I tell all my faculty, in my college, I have 250 faculty, and I tell them all that tenured full professor is the best job on campus, right? It's much better than being a dean. That said, the reason I became a dean is really sort of two things. Very few people, go through the path of getting a PhD, getting a faculty job, getting tenure, getting promoted with the idea that they're going to become a dean, right? So what happened was, about 10 little more years ago, other administrators started asking me if I would do administrative roles, and they were usually people I had a lot of respect for, and so they were friends and mentors of mine, so I would say yes. And it just, at some point, it became clear that I was pretty good at it, right? So, and then the other, one, it was this combination of opportunity, getting asked to do things and succeeding. But, honestly, I really enjoy parts of it. And the reason why is because I get to make, if I'm doing my job well, I'm making the lives of all my faculty and staff better. Right. So I'm creating environments in which they can succeed. And as someone who used to be in that position and benefited from people doing that for me, I find that very rewarding. And so it's a very different kind of job. But when I see a young faculty member who's, getting grants because we've bought them a bunch of good equipment and given them good lab space, that's satisfying. When I see our faculty creating new courses and doing a great job teaching and helping students, that's rewarding. You know, we're building a brand new, almost $100 million building that's going to be full of classrooms that are going to benefit our students. And, you know, going out and getting those resources and making that building happen so that we can give our students a better educational experience, that's rewarding, right? So it's a different, you know, it's a different kind of satisfaction. And it's not for everybody. There's some really hard things about this job. But there's no question I miss not being in the classroom. You know, I haven't taught a class now in 8 years. I miss, you know, I finally stopped doing research a couple years ago because I just didn't have the time, and I miss that. But, you know, we all have to make decisions like that.
Yeah, that's really cool how you're kind of like paying it forward. But my second question is a little less serious, but if you had to pick, like, would you rather only work in like aero type sciences or only work in like space type sciences? So like planes or spaceships?
Spaceships. Yeah. I mean, they're both really cool, but the reason space for me is, you know, goes back to sort of when I said there's sort of a philosophical piece to it. Well, I'm fascinated by astronomy. There was a time when I thought about going into astrophysics. When I was an undergrad, there was one semester when actually 2 semesters when I took 21 credit hours of courses so I could take some astronomy classes. And so this idea of sending these, understanding space, and I don't know, I think it's just really cool. And it's also, as I was saying earlier, it's really cool engineering. So.
Well, thank you for answering my questions.
Yeah, absolutely. Thanks.
21 credit hours.
Yeah, it wasn't the smartest
That's
decision
incredible.
I made as an undergrad, but it was fun. They were 2 tough semesters, I'll tell you.
Yeah, did you get any sort of sleep at all from that?
I suffered those 2 semesters. There's no question, and I'll, you know, so when I was an undergrad at Virginia, my best friend was an English major, right? And you know, he's my best friend to this day, actually, right? So, but his academic schedule was a lot different than mine, and so it was a little, particularly that semester, was a little challenging.
Yeah. Gavin, do you have a question you want to ask too?
What degrees would you like recommend getting for like the space field?
Oh my gosh. You know, you can go into the space field with just about any engineering degree, quite frankly, as everybody, you know, I think people tend to think that aerospace or aeronautical engineering is the engineering that you need to go into space, but it's really not. You know, the chief scientist of Boeing is a UNL grad and is on my advisory board, and you know, and he would tell you that they hire very few aeronautical engineers at Boeing, right? Of course they do have some, but they hire far more mechanical engineers, electrical engineers, and software engineers and materials engineers, right? Because the complexity of both planes and space vehicles is just, you know, it's just so complex, and it uses expertise from so many disciplines. I mean, pick one of Boeing's products, you know, the 787, right, with the composite body, right? So that's a lot of materials engineering. You know, for unfortunate reasons, you've heard a lot about the control system in the 737 MAX, right? That's a software engineering and human factors engineering issue, right? So, you know, so you can go into space with many engineering degrees, but certainly, you know, mechanical, electrical, materials. If you want to work on rockets, you know, chemical engineers have to design those fuel systems, right? And so, yeah.
Yeah, absolutely.
Thank you.
Yeah, absolutely.
Casey, do you want to ask?
Yes, I have a question. What mistake in your career has given you the biggest lesson to this day?
That's a well, yeah, I mean, gosh, depends a little bit on the context, but so the answer I'm going to give you is sort of very specific to being a professor. So if this isn't what you're looking for, feel free to ask your question again. But the worst decision I made as a faculty member. So as a faculty member doing research, you have to write grants, right? So you're writing grants to things like the National Science Foundation, NASA, the various Department of Defense agencies, Department of Energy to get funding for your research. And so there is this, you are playing this game a little bit of chasing money. And the worst decision I made was I got involved in a multi-university project. And I did it for the wrong reasons. I did it because the opportunity to get research funding was there rather than the fact that I cared about the work being done. And it was a miserable 3 years doing work you don't want to do, right? And I've done many complex projects like that, and most of them have been great, but doing that one where it was a project that I didn't believe in the work, it's not that the work was bad or anything like that, it's just something that didn't interest me, right? And that was a horrible 3 years where having to have it, in any career, you wind up having to do work that doesn't interest you, right? I mean, because there's work that has to be done. As dean, I do lots of things that I don't enjoy, but it's work that has to be done. But, to consciously make that decision that way and tie myself into something for 3 years, that was awful. And I never did it again. So I don't know, was that responsive to your question?
Yeah, thank you.
Absolutely.
There's another one, a question I wanted to ask Dean about the Complete Engineer Initiative, which I know has been a really big project for the last, I don't know how many years. But the question I wanted to ask is, where do you see that going in the future? And what's your vision with the Complete Engineer Initiative?
Yeah, again, you guys are really hitting it out of the park with questions. That's it, because it's almost like you've been in my office the last year, because these are all the things we've been talking about. Yeah, so the Complete Engineer. So first of all, if at the highest level, what the Complete Engineer is a program that develops non-technical skills in our students, right? There are 6 of them that we've articulated, and these are things that you need to be a good engineer. That's why we call it the Complete Engineer. There's a stereotype that an engineer, is she's the person that sits in her cubicle, right? Stares at a computer screen all day, drinks Mountain Dew, right? Doesn't, doesn't talk to anybody. That's not engineering, right? Engineering is a very collaborative, interdisciplinary, people-oriented profession, right? You have to be able to communicate. You have to be able to work with other people. You have to, be able to discuss things and debate. And so you have to understand, engineering is also a very global, a very global profession. And it doesn't matter if you're working for Boeing, which is obviously global, or you're working for Orthman Manufacturing in North Platte, right? Which has Orthman Manufacturing, is a small manufacturing firm in North Platte, Nebraska, but they sell their farm implements everywhere around the world, right? And so engineering is inherently global. It has it's very interpersonal, and it has a lot of communication. So the Complete Engineer is about really trying to develop those skills in our students. So our core curriculum is primarily about technical proficiency, all right, which is of course the foundation of engineering. the complete engineer is about giving our students those other skills so that you really do graduate with everything you need to be a successful engineer. So the program has been around for several years. It's sort of in a pilot stage as we tried to figure out what worked about it, what didn't work about it, how, were the competencies the correct competencies, how would we assess them, how would we document them. And so we've spent the last year really working hard answering those questions. And in the fall, we're going to be rolling out the complete engineer sort of in a very formal way, where we have rubrics now for assessing students' competencies in these skills and with respect to the 6 competencies. We have a way of documenting it now. We're working on getting it showing up on students' transcripts. I don't know if you just saw, we just had a news release a couple days ago about the Kiewit Scholars Program. So the Kiewit Scholars Program is a new scholarship program for engineering students. It's being funded by the chief executives of Kiewit, and we'll have a total of 40 students in it when it gets up and running. But the complete engineer students who receive a Kiewit scholarship have to participate in the complete engineer and have to achieve a certain level of attainment in the competencies. So I think so a couple of things about that both means that it's going to be very real now, as it's been a little bit amorphous for the past several years, but also the fact that a company would endow a scholarship fund and require our students to participate in the program demonstrates how much it's valued by industry, right? And Kiewit's a very practical engineering company. They wouldn't require students to do it if they didn't want their future employees and leaders to have those skills.
Okay, thank you. And
Yeah.
also kind of a follow-up question to that. Have you heard feedback from companies like Kiewit or other industries about how improved students are with the Complete Engineer Initiative? Like, are they seeing progress with that?
Yeah, so our evidence prior to now has been twofold. One is things like what Kiewit is doing, where companies tell us, this is an important program. We really want you to implement this across the college. And then the other is some anecdotal evidence where I had a recruiter for Microsoft come up to me after one of the career fairs and say, your students interview so much better than other students. And when I asked them why, they said the Complete Engineer Program, right? That when they were being interviewed, they didn't just talk about their grade point average and the courses they took. They talked about what their broader educational experience was, how all these technical and non-technical skills were going to make them a better engineer. And they were very impressed by that. And I've had several employers say that the students that they've had who've talked about the complete engineer are just better. They come into the company better prepared. They generally advance in the company more quickly too.
Okay, thank you.
Yep, for sure.
MJ, looks like you have a question.
Yeah, kind of related to that. I guess you talked a little bit about the rubric, but what's a way that, I guess undergrads or even like the students now can kind of check themselves to make sure that like they are developing the non-technical skills like communication and stuff like that?
Yeah. So I think there's two pieces to the answer to that question. The first is we are going to be rolling out a system in the fall that will allow, give students a mechanism for documenting how they're progressing through these competencies. And we have the essence of it is students who want to do this will put together a sort of an electronic portfolio that we will have trained people evaluating and giving students credit and according to these rubrics. Okay. So the second part answer to the question is this. There's a philosophical point to this, that at Nebraska, the kind of you know, our whole premise is we believe in the residential educational experience, right? The fact that we don't deliver our curricula online. And now forget about COVID and the pandemic and everything that's going on right now, but what we do is we ask students to come to either Lincoln or Omaha and to really live at the university, even if you're living at home and community, but you come to the university to get your education. And the reason for that is that it's about that residential educational experience. So it's not just that you come and take courses, right? It's that you come and you're in the engineering buildings and you're interacting with other students, you're working with RSOs, you're doing undergraduate research, you're doing all these other things. You have a study group, right? And when we think about the complete engineer, if you want to really, so we have 3 levels of attainment for each competency: exposure, engagement, and transformation. If you want to move up through those levels of achievement, you're not going to get it just by taking courses, right? So one of our competencies is leadership. So if you want to move up in the leadership competency, we have a minor in leadership, and Karen Stelling is really critical in that. You can do that, and that will help. But at some point, you have to get leadership experience if you're really going to transform yourself with respect to leadership. So, are you going to take a leadership role in a student organization? Do you have a campus leadership role? Did you, take a leadership role in your capstone design group? So what part of the complete engineer is going to be students working with us to design their broader educational experience so that they can achieve higher levels of attainment in the different disciplines. So if you think, go ahead. It looks like you have a follow-up question, so I'll be quiet.
What are things that you think, like, pre-college, like the students here could do to be working on these skills already?
I think it's, participating a lot in extra and co-curricular activities. And also in a broad set. So, one of a critical competency is various forms of communication. So are you participating in debate team or speech team or something like that, where you are practicing and getting comfortable with getting up in front of people and talking, and right? So that's one way of doing things. Sorry, my wife is just leaving. So it's getting into that broader set of experiences, because it really is the key to education, in my opinion. Is, of course, there's coursework, and that is the foundation of education, but it's that broader set of experiences, whether you're in middle school, high school, or college, or graduate school, quite frankly, that really is the full educational experience. And we'd be happy, I'd be happy to come, and if you want, or have one of my staff, talk more about the complete engineer, about the competencies and that, if you guys would like at some point. And happy to share information with you about it too, if you want to read about it. It's a really important program. It's going to be a real differentiator for our students and our graduates.
Yeah, it sounds like it. It's a great opportunity. Tegan, do you want to ask a question?
I have another question. So you talk about like doing extracurriculars and things like that. Do you think it's good to do extracurriculars that aren't just tied into like a specific like science? So like if you're interested in mechanical engineering, but you do like electrical engineering, and then you do like musical activities and then like a sport, do you think it's good to like just show overall that you're a balanced, well-rounded person? Or
yeah, absolutely. I think so the short answer is yes. A broad range of interests is always great. And I think, now that I'm sort of on the other side of that, where, we're making admissions decisions, and we're always talking about how we admit students and how we select them for scholarships. When we look at our student applications, of course, we look at things like grade point average and class rank and ACT, but we're also looking for those other things. And, you know, I think these extracurricular activities do really two things. You know, one is it demonstrates that you are a well-rounded person, and we know that being well-rounded is important to being a good engineer. But also, it demonstrates that, you know, your ability to sort of to manage your life, right? So if you play an instrument and you did that, you know, you played clarinet the entire way through high school, boy, that's a big commitment, right? And it's a lot of time. So you had persistence, you had you got, you know, you were able to get better and persist, and you were able to manage your time while going to school, right? So it goes back to sort of where we started. What makes a good engineer? Those extracurricular activities, even though playing the clarinet may not seem like it's important to being an engineer, it demonstrates that you have this skill set, right? So I would encourage you to pursue the things you like and get involved.
And do you guys ever look at like rank amongst like different things like that? So like in things like orchestra or band, do you have like chair seatings? Or like if you do like debate, like how did you win like a state level tournament? Do you like things like that? Or is it more of just like, did they involve themselves with it?
It's more about, did they involve themselves? Yeah.
Thank you.
That's a good question. I have another question, Dean Perez. It's about the future of aerospace in Nebraska, because that's one of the main missions of this Big Red Sat team, is to eventually develop a strong aerospace industry in Nebraska.
Right.
So do you or the College of Engineering have plans in the next 5 to 10 years for advancing aerospace in Nebraska?
The short answer is we don't have a really concrete plan around that, right? And the reason I would, so part of the reason, I mean, you have to realize what our core mission is, right? So our core mission, we have 3 components to our mission in the College of Engineering. So it's education, right? It's research, and then service to the state and to industry. So as we go across those missions, we do ask ourselves what the role of aerospace is, right? So we have, you know, every couple of years we ask ourselves, should we try to offer an aerospace undergraduate degree, right? And you know, we've done studies and had outside firms do studies, and there's never a really compelling justification for creating aerospace engineering as a degree program. And part of that goes back to what I was saying about, you know, my board member who's at Boeing, is there's just not a big demand for aerospace engineers. And if you want to work in aerospace, you know, if you get a mechanical engineering degree, you can take a lot of courses that are in an aerospace engineering degree, fluid dynamics, heat transfer, right? Things like that. And so, but actually creating a degree program, we evaluate it. If the conditions are ever right, we would certainly consider it, right? But it just hasn't been able to cross that threshold yet. We've talked about, more likely is we'll create an aerospace minor, so that students know which courses to take to get the more aerospace flavor. And we think we can do that relatively straightforwardly. When we think about research, our faculty do some research that's related to aerospace, right? So across all of the disciplines, but it doesn't necessarily, you know, but it's not that doesn't necessarily translate into specific industry presence in Nebraska, right? So, you know, so then there's service, and, you know, so there are aerospace companies in Nebraska. We do, you know, they do hire our graduates. We do have some relationships with them, but we're not positioned to directly impact the investments of industry, right? So if Boeing wants to create needs a plant somewhere, they make that decision independent of us, right? So it's a good question, and we think about it, but it's hard for us to have a lot of impact on that. What we hope in the longer run is that as we continue to grow as a college, continue to produce great graduates, continue to expand our research enterprise, is that more and more companies will think about locating in Nebraska, right? And that we will grow a variety of sectors, but that's a pretty long-term proposition. But yeah.
Yeah, that makes sense. What are your thoughts on Space Force in Nebraska?
Well, I hope they reconsider the decision about sending it to Alabama. I was actually surprised by that decision. I know the state leadership was working really hard, and I was really hoping it would come to Offutt. So we'll see how the politics plays out. It would be a great thing to have in Nebraska.
It certainly would, yeah.
Yeah.
Thank you.
Sure.
Does anybody else have any questions?
Sorry,
Right.
no, I'm making lunch right now.
All right.
Dean Perez, before you go, how do you think this Big Red Sap program could, what do you think of the program overall and what its impact could be to middle school and high school students?
Well, I just think, these kinds of experiences, they came up in a lot of the questions and answer today. They're just invaluable, I think, to the students who get to participate in them. It's part of the reason we're so supportive of this, John, is we really think that this can be a transformative experience for the students that are involved. It's a real engineering experience. It is cool. It's challenging. It will give the students an opportunity to be exposed to real engineering. And a lot of the things we talked about today, you guys are going to see is you're going to fail, right? Things are going to break. You're going to have to go back to the board. You're going to have to be creative and persistent. You're going to use science and math. You're going to do cool stuff. You're going to have late nights. And then you're going to see this amazing achievement when it launches. So I think it's a great thing, a great experience. And, and when you're applying to college and you have this on your application, people will notice. So it's a great thing.
Thank you.
Absolutely, John. Thank you for all your leadership on this. Really appreciate that. All right.
Well, thank you so much for coming to talk to us today. We really appreciate it, and we appreciate all of your support for the Big Red Satellite Program and the Aerospace Club, and just engineering in general. We would also like to invite you, if you're interested, of course, to our high altitude balloon launch that we're doing. I think the tentative date is April 24th at the SAC Museum.
Oh, cool.
And that's a project that both AXP and this Big Red Sat team are collaborating on.
Great. Well, thank you. Yeah, if you could send me an email so I can try to get that on my calendar. I'm definitely interested. My calendar is complicated, but I would love to see it if I could. And thanks very much for this invitation. I can't imagine you spending an hour of your Saturday morning talking to a dean. So I really appreciate you taking the time. Really great questions. If there's any point we can do anything more to help this group or to answer questions, or if you want to come visit the college and learn about some stuff, just let us know. I'm happy to do all we can. And great questions, really great questions. So good luck with your project. It's important, and I wish you the best.
Thank you.
All right. Have a good weekend, everybody.
You too.